Okay, one more example of how something might look that looks a little hard on the surface, but it's actually not that hard. 500 kilogram dragster accelerates from rest to a final speed of 110 meters per second in 400 meters, about a quarter of a mile. Yes, track. And encounters an average frictional force of 1,200 newtons. Okay. What is its average power output in watts and horsepower? Okay, don't care about that so much, but that's fine. If it takes 7.30 seconds. Okay. All right, so we're looking for average power output, so we know we're looking for work divided by time. Okay. Work, we need to find somehow. Okay. It kind of tells us the friction. Okay. But it's asking for, let me look at this real quick. Okay, average power output. Okay, so when they say this average power output, we're talking about like from the engine. Okay, not the friction involved, right? Power output would be like of the device. Okay, so we're kind of trying to look at what power or energy is being provided by whatever's happening in the engine. Okay, so if we make a little photo, okay, we're going to have some kind of force forward, right, from the engine or kind of, I don't know, whatever that thing is that's providing that power output. This is the thing that we want the power of. Okay, that force that is causing this engine to go, let's just say, I guess. Okay, all right, so if I think about my LOL, all right, initially I have no kinetic energy. Okay, work is going to be done by the engine. Okay, and work is also going to be done by friction out, right? Because those two things are kind of fighting each other. And then I'll be left with some kinetic energy. Okay, so I would say 0 plus the work done into the system by the engine minus the work done by the friction is going to be the kinetic energy. Okay, so the kinetic energy is going to be, oops, nope, I don't want to say that. The work is going to be the final kinetic energy plus the work done by friction. That's how much it has to provide, right? The engine has to provide enough to make it be fast and overcome whatever is happening with the friction. Okay. All right. So if we look at it like that, we'll have 1/2 mv squared plus force of friction times that distance. Okay. And let's see what we've got. 500 kilograms. Okay, and we know the final speed was 110 squared, so we should probably maybe write some of this stuff over here. Time, 7.3 seconds. Friction was 1,200. And the displacement was 400 meters. Oh, that was convenient. Kind of gave us everything. Okay, so then plus the force of friction is 1,200 times 400 meters. Okay, and right, remember we're just plugging in a positive 1,200 for magnitude because we've already taken into account here that the friction is like opposite the motion, okay? So when we moved it to the other side, that's going to be positive. So don't re-negative it anywhere, okay? Oops, that's what I want. Okay, so the work done by the engine is going to be 3,025,000 joules. Plus the friction work is 480,000 joules. Okay, so that gives me a total of 3,505,000 joules. And that's the work done by the engine. That's the power output that we're looking for. Okay, all right, now I just have to divide by the time. 7.3 seconds to get 480,000 watts. Okay, that's my first answer. Okay, all right. And then if we do want to change that to not kilowatts, to, horsepower. Okay, 746 watts is what we call 1 horsepower. So that would be 644 horsepower, right? So cars are more normally labeled in horsepower, right? We don't label cars in watts and stuff. Okay, all right. So this is kind of also a pretty common thing that you might do, all right? When solving a power problem, okay, you may do some kind of conservation of energy thing, okay, to find whatever work is that they're asking for, okay? And it might be like the overall work. It might be the work by friction. It might be the work by the engine, whatever. But usually it's kind of like they say this power output thing, which they're talking about kind of the power produced by the device or the car or the whatever. Okay. If on one of the WebAssigns, I think, right, like if this also went up a hill or something, right, I'd just have some UG over here, or if it had come from a hill, there'd be some UG over here. There could be a spring involved, but probably not, right? So just keep in mind, you can kind of just use this general conservation of energy thing to find whatever the work is that you're looking for, and then just divide by time.